I'm going to explain the theorem. A countable set has outer measure 0. Okay. Here is the proof for this statement. To prove this theorem, what we have to do is, first the statement is a countable set has outer measure 0, right? So for that you have to first take the countable set, that is, let A be a countable set. So let that countable set, the elements of countable set be this, okay, x1, x2, etc. xn be the elements of A. Let epsilon greater than 0 be given. Then what we have to do is, let x1, the element, choose the first element. This x1 is covered by the interval I1 and the length of this interval is epsilon by 2. You are considering like that. Similarly, let x2 is covered by I2 of length, covered by the interval I2 of length epsilon by 2 square, etc. xn be covered by the interval in of length epsilon by 2 power n. So total length of the interval is given by, now what you are doing is you are adding all the intervals, that is summation L of in is equal to epsilon by 2 plus epsilon by 2 square plus etc. plus epsilon by 2 power n plus etc. Now you are taking epsilon by 2 common, so that you get 1 plus epsilon by, you have to take epsilon by 2 outside, right? So that is why you get here 1 plus 1 by 2 plus etc. plus 1 by 2 power n etc. So here this is of the form 1 plus x square plus etc. So that is, this is in this form. So we have a formula. If it is like this, then the formula is 1 minus x the whole inverse is equal to this expansion. Okay, so here you have this this expansion. So what you are going to do is, you in the place of this you are going to write this with the help of this formula. So you are writing 1 by 1 minus x. Here x is 1 by 2, right? So that is why 1 by 1 minus 2. So that is equal to epsilon by 2 of 1 by, you will get 2. Okay, you get 2. Epsilon by 2 into 2. So cancel the 2's. So you get epsilon. So since epsilon is arbitrary, we get summation L of in. This summation L of in is equal to 0. Okay, taking infimum on both sides, so that you get infimum summation L of in is equal to 0. So for this value, by a definition of outer measure, I think by the definition of outer measure, yes, by the definition of Lebesgue outer measure, you can put m star of A in the place of summation L of in is equal to 0. So hence the proof.